So in the shack here at N9KR, we found that in addition to a good multimeter and some hand tools on the bench, one of the neat things to have is a 12-volt source of pure DC, and these little APC or other branded 12-volt gel cells that come out of uninterruptible power supplies, UPS, is typically in a PC environment. These things are just perfect. And we've got 2 or 3 of those here that we keep available on the bench for that exact purpose, for projects, QRP work, testing, any place where you need a good 12 volts, nice clean pure DC. These things work great. This particular one, this 800 APC 800, had 2 of the gel cells. Some of them only have 1. But again, if you have a unit with 2, if the units have been thrown away or disposed of because the batteries are dead, very often there'll be 2. If there's 2 batteries in it, very often one will still be good, which was the case with these exact 2 we pulled out of that unit. One of them won't take a charge at all. The other one is still fine, and that's the one we're working with right here. I'm going to use in this demonstration. So, as good as these gel cells are and as handy as they are around the shop, around the bench, the problem is, or one of the problems is, how do you keep them charged up? How do you keep that voltage topped off in these units? And one of the ways that we had done that, which was not very efficient, was to actually, when they drop down in voltage, is put them back in an APC unit and let that circuitry recharge them, but that's very unhandy. So we thought, why don't we go ahead and look into building up a charging circuit for these. It can't be that difficult. And we looked around the web, and sure enough, it's not that difficult. And as a matter of fact, we can build a decent little charging circuit with a total of 9 components. And these guys here represent what's involved in building a circuit. It's very common. A lot of guys on the web, you can Google gel cell battery charger, and you'll find lots of examples of this. So here's all the components that are involved. A little LED. Here's our LM317 voltage regulator. Little general purpose NPN transistor. It can be a 2N2222 or a 3904 or anything similar. Nothing special about those at all. A little variable potentiometer here at 5K. 3 resistors. One of them is a 470, one is a 2.2K, and the other one is a 1 ohm resistor at 1 watt. And then a couple of little bypass capacitors here at 0.1 microfarads. All together, I'd say all these parts are probably less than 75 cents. And you may have many of them already in your junk box. So the only additional things you're going to need are a perf board or a little scrap of copper like this, or something to build this guy on. And by the way, I found a Dremel tool with a cutting wheel on it. Is just excellent for working with these copper-clad fiberglass boards. We use a lot of them in our ugly style, Manhattan style homebrew projects. But in this case, what I did was I had a little piece of 2 by 3 inch piece of perf board. It's kind of perf board on one side and copper on the other. Has the little holes in it that work well for the through-hole components. We went ahead and used this, and as you can see, it's still built ugly style. And built this up in about an hour using those components that we just looked at. And basically, I have the LM317, which just does generate quite a lot of heat. There's a heat sink on here that you're going to need. This one's just a little aluminum heat sink that came from some other project, and it actually, as it turns out, probably not quite adequate for the amount of heat that comes off of this guy when it's charging a battery. But so there's the LM317, little LED down here, variable potentiometer over here for adjusting the output voltage. We want to set that at 13.35 volts. The transistor is over here doing its job, and the variable and the bypass caps and the resistor over here. The back side is a little sloppy. It's just basically hacked together here pretty quickly. That additional resistor on the back side is just one that we added in parallel with this little float resistor up here. It's kind of hard to see, but that's to get the exact 1 ohm that we needed to make this circuit work correctly. Okay, so there it is. This is our gel cell charger in kind of rough form. It ideally would be in a case, which would be a good idea. Our input over here, voltage connects up to this side over here, ground and hot side. That can be any source as long as it'll provide at least an amp of current, 1 amp. Any source 15 to 18 to 20 volts will work. And our output is taken over here from the ground and our output pin. In each case we use alligator clips and jumper wires for these guys. And so here's our gel cell battery charging circuit, courtesy, in this case, of KC8AON. You'll notice that our indicator in this case is a meter, a small meter in that LM317 to transistor circuit, the 2N2222. You can also use an LED in there. The process being that when the battery first is connected to this charger, if the battery condition is low enough, then the current will flow through that meter, or the LED lighting it, or indicating on the meter, and then as the battery begins to take on a charge, that will drop down less and less until there's no indication on the LED or the meter is down near zero. In our case here, we've actually built the unit with an LED, but let me move up a little closer here. And there's our. We've included a meter because the LED in most cases won't show much brightness at all, and it's easier to see the current flow in the meter. Okay, so we got our set up here. We'll kick the power supply on. We can see we got a meter in the circuit there showing the input voltage, and right now it's actually showing what the voltage is coming back through the battery, just over 12 volts. Which for a gel cell is pretty well discharged. They'll typically show between 12 and 13 volts. So we'll kick on the 18 volts input from our power supply that's up out of the way that you can't see. Keep an eye on that meter. That will show a relative current flow inside the charging circuit, and the idea is that as that meter drops off, the system switches over more from cycling charge down to just a float charge, and this little charger will keep it in float mode basically forever. If you want to leave it in all the time, although I typically don't do that. We'll kick the unit on here now. We'll kick on the power supply, and we can see our little internal meter kicks up there. It's all just a relative indication. This is a little unit that came out of an old CB or something, and you can see that dropping off. And it's our supply voltage showing up on the fluke meter in the back at 18.7 volts. And that current flow indication on that meter would eventually drop off all the way down to zero. We'll switch over and take a look at the voltage at the battery. That charging voltage should be pretty consistent. It's a constant voltage source, and it should be just about 13.5 when it finishes charging. When it changes over to the float mode, it'll be just about 13.5, 13.4 volts constant. Okay, in the way of a recap, we've got our gel cell here and our little kind of hacked together gel cell cycling charger and float system that without all the encumbrance of having all the cables and the connectors, meters and things connected up to it. And we want to go ahead and provide some power to this guy, and then we'll set it up on this battery to charge. We're going to use, in this case, we're going to use this little bench power supply, Radio Shack supply. It's good for about 1.5 amps at anywhere from 0 up to 24 volts. So we're going to use that at 18 volts. We could have used a wall-wart similar to that one. The problem is that it's going to have to be one that will provide at least a 1 amp of current for you and be in the 15 to 18 volt range, and those are a little bit harder to find. So we're going to use our little bench power supply right now. So what we're going to do is connect up our red lead and our ground lead on the output side of our circuit. This is going to be the voltage that flows into our battery. And I think we'll go ahead and add a little clip-on alligator clip just for some additional heat dissipation to that heat sink on our little charger circuit. And then on the input side, we'll connect up our ground lead and connect up our positive lead going back to our bench power supply, and then we'll kick on the supply. And there we go. We're going to be charging on the input side at right around 18 volts, and on the output side we should maintain a steady 13.5 volts into the battery. And as that begins to take on a full charge, the flow charge will drop down to almost no current flowing. It'll maintain just about a 13.4 volt charge on the battery for as long as you want to leave it connected up, which should keep it in full charge status for you on your bench.